Hello and welcome to this video on network policy with Calico, an overview. My name is Rob Bagby. I'm an engineer for Microsoft, and over the next 10 to 15 minutes or so, I'm going to talk to you at a very high level about Kubernetes networking and why there's a need for network policy implementation within your Kubernetes cluster, and then I'll give you a working example of using Calico for network policy on a very simple workload. So to start with, let's talk a little bit about Kubernetes networking. Now, Kubernetes uses a plug-in model, uses a CNI plug-in model. And so there are a variety of providers that you can choose from. Now, each of those providers, however, has to adhere to the requirements set out by Kubernetes. And that is that every pod needs to have its own IP and can address every other pod in the network. So there's a challenge therein in that if you get breached, you pretty much have carte blanche to everything else within the network, which is likely not what you want. So to give you a visual, this is the default behavior. If each of those white blocks is a pod, they can communicate with every other pod in the network. And maybe this represents what your desired behavior is. Or another way to look at it, this is the default behavior, and maybe this is the desired behavior that you want. So how do you handle that inside of Kubernetes? The answer is network policy. So what is network policy? Well, network policy is an actual Kubernetes resource, and again, it's a plug-in model where you can have differing implementations of network policy. The process by which you go is you deny all traffic by default, and then you allow traffic based on labels. And so here's a very simple example, and this is the one I'm going to show you in the demo coming right up. I've got two containers. I've got one that's an API or represents an API, and another one that represents a web page that consumes the API. All either of them really do is return the host name that they're running on, but that's neither here nor there. On the left-hand side, the little thing that looks like a 3.5-inch disk is actually an icon for a web browser that I found online. So you go from a web browser, you hit the web application, and then the web app consumes the hostname API. So at the very top, you can see I've labeled each of these. So the web app has the label return hostname web, and the API has the label return hostname API. So what we're going to do is we're going to set network policies. On the web app, I'm going to allow ingress from everywhere, but on the API, I'm going to allow ingress only from those workloads that have, or pods that have a label of app return hostname web. So with that, let's take a quick look at what these policies look like. You can see this is the deny all traffic policy, and you'll see there's a spec pod selector for every pod, but there's no ingress from. And so we're not allowing any ingress from anyone. And so, so this is kind of that default deny all. Now these are the allow policies that are going to basically whitelist who we're allowing ingress from. So the network policy on the left is for the web app, and you can see that the pod selector is so for the web app itself, the return hostname web, and it's allowing ingress from everyone. Okay. On the right-hand side, you can see this is the pod selector for the API, and it's allowing ingress only from those that match the labels app return hostname web. And so only the web app is going to be able to communicate to our API. So let's pause here and take a look at a demo and show this actually working. For the network policy demo, I've got a file that's going to deploy our two applications, the return hostname API and web. You can see it's just a typical YAML file. We've got a deployment here that has the return hostname API. It's exposed over port 5000, and the important bit here is that the label under its labels, it has app return hostname API, and it's exposed as a service. It's just a cluster IP service, and that's mapping port 8080 to the container port 5000. Then we've got another deployment for our web. Again, it has the label app return hostname web, and it has the container port of 5000, and then it has the service, which is a type load balancer, which is, because we're running in Azure, is going to deploy out an Azure load balancer, and it's mapping, again, port 8080 to port 5000. So we can go ahead and run this. So I've got a terminal here, and I can just do We can do a K create -F. I have a alias to K to kubectl. And then we will do return hostname LB, and we'll pause the video for just a moment while all of these services are being created. Let's go ahead and just do a search to see what's going on before we pause it. And you can see the services, the two pods are up and running here, but the service is waiting for that external IP to be deployed, because that's getting created in Azure as we speak. So I'll go ahead and pause this until all of that's created. Okay, as you can see, our external IP address is there, so the load balancer has been provisioned, and we've got a public IP address. So we can actually go and go to a browser. So let's copy this, and let's open up a browser here, and let's just go to http:// and if you remember, we are going port 8080, and we should see the result of the return hostname web, which basically calls into the web API and then writes out the web API's hostname and then writes out the hostname for the web app itself. So we got this, we've got our app up and running. What we can do is we can go back here, and what I'm going to do is I'm just going to go ahead and do a kubectl run, and let's do busybox, which is a very small image that I can do some wgets from to test the connectivity from services within that cluster. So let's go ahead and do get this up and running. And so now we're going to be running inside of this container, and because I did -IT, I've got an interactive terminal here, and so now I can do a wget to those services themselves. So let's do wget, let's do -q, and we'll do http:// and then we want the service name, which is going to be return hostname web v. Let's see, the service name is web. There we go. And so then again, that's port 8080, and then let's just do a timeout of 5 seconds, and let's see, and let's just write it out to the screen, and you can see that we were able to make a call from within the cluster to that service via its service name. I can also do make the call into the API, but this clearly isn't really what we wanted to do. If you remember, we wanted to make sure that everybody can connect to our web app, but we wanted only the web app to be able to connect to our API. So to that end, let's go ahead and take a look at some of the network, running those network policies we looked at earlier. If you remember, we had the original default deny, which is this network policy. Default deny, it's a pod selector of everything, and then no ingress. So we can run that. So let's go ahead and run that. And that's going to be, let's see, default isolation. Okay, so now if we run this and try that same wget, we're going to see that it's going to time out. We're not able to connect to it at all, that's actually a good thing there. However, we can't get to our web app either, and we can see that by going again out to the browser. We'll open up a browser here in a second, and let's try again. We've got to get the URL. There we go. And we're going to see that we're going to time out here, and things aren't going to work there either. So what we need to do is we need to set the enable policies to allow us to actually connect. So if we go back to code and take a look at the enable access policy, these are the two policies we looked at in our slides for the access return hostname API. For all those pods that match return hostname API, it's only going to allow ingress from return hostname web. So that'll enable our web app to run. However, we shouldn't be able to connect to it from our busybox image. And then for the web, we're going to allow ingress from everyone. So let's go ahead and create these. And those two are created. We'll give them just a quick second here. Let's go back out to our browser and stop this thing. Let's just open up a new tab here. And this, if those policies have propagated, should be able to connect. And while that's thinking about it, let's go ahead back into here and let's see if we can connect to the API, which we shouldn't still be able to. So we're not able to connect into the API. We're going to get a timeout. Same thing as before, but our web app works. So we're able to get to the web, and we're able to lock down the policies that we wanted. Now we can take one more step here and illustrate if I were to go ahead and exec into that web pod, then I should be able to connect to the API, which I wasn't able to from my BusyBox. So we've got our pods over here, and so this is the name of my web pod. So let's go ahead and copy that, and I'm going to do a kexec -it, and then we'll just paste in that name of our web app, and then let's just get to a shell. Okay, we're there. So now I should be able to do a wget, and we should be able to run the same exact wget here. So let's copy that and paste it, and you can see that it did work. So hopefully this demo has been able to illustrate to you how easy it is for you to set up policies to deny all communication, and then allow you to set other policies that are going to whitelist. Now, obviously the labels I used, I had app with the name of those, but that was really just for demo purposes. You can set whatever labels you want. You could have customers and labels, customer names, or you could have environments, etc. So you've got dev, and you can have which is it, front end, is it mid tier, etc. Really, the sky's the limit. The net is that network policy with Calico doesn't care. You're just able to define the rules via those really flexible label model. So hopefully it's been helpful to you. If you have any questions, you can reach me at rob.bagby@microsoft.com.